As you can see over here, we just have a tertiary haloalkane at the moment. Let's just say these are like partial line structures, but with also letters. So this would actually just be another methyl group over here. Methyl groups on the side on all of them. I'm just not going to draw them in for clarity. And over here in the Sn1 mechanism, we know that this chlorine is a leaving group. It's going to leave. It's going to form a chlorine ion, and we have our carbocation over here. What I would like to point out, and the reason why I'm doing this in VR and the importance, I know there's like a million videos on this. The reason I'm doing it in VR is because if I like look around the molecule, you can see that it is a sp3 molecule. But on this molecule, if I just bring it over here to the side and I try rotating it around, you can see that it's a plane, it's flat. So that means one of two things. First thing it would mean is that it is sp2 hybridized, so that means it's 120 degrees bond angles across the three methyl groups that are around it, because remember the chlorine left. And the second thing it means is that if we have our base that we're using for the Sn2 reaction, it can either come from the top or it can come from the bottom. And that's exactly what we have over here. So the base that you're going to be using in your Sn2 reaction would be able to approach it from the front or the back. I mean, there's no other better way for me to explain it in VR other than looking at the side and seeing, showing that the oxygen, the partial negative charge on the oxygen would be able to approach from the back, or it could approach from the front like this, and that would obviously cause a bond to form. So let me just take a piece of this and make a bond. So obviously this would then have a positive charge on the oxygen, and that would be deprotonated later on. I'm just going to remove it for simplicity's sake, and that would be an H plus in solution, technically. Or if your professor wants, they would ask you to deprotonate it with another water, but whatever. So this would be one of the products formed. Or if it was able to approach from the back, then it would look a little bit like this. And now that we have these two products formed, we can compare them, and we can look at them and be like, hey, wait a second, they're the exact same. Well, yeah, they're the exact same because this isn't a chiral center. By definition, a chiral center should have 4 different groups on all sides. We have 3 groups that are the same, 3 methyl groups, and we have hydroxyl. Oops, I should get rid of that water over there, that extra H, and we have hydroxyl. So if we compare them and we're able to rotate this around, right, because that's essentially how you figure out stereo isomers, you can see that we basically have the same molecule. So would a racemic mixture still be produced? Well, no, because we don't have a chiral center. When people say racemic mixtures are usually created by Sn1 reactions, you have to be careful because it depends on your reactants, and it specifically depends on what carbon compound you use for that reaction. So for example, in here, it wasn't. But let's say if I was able to change that over there, I had, I don't know, a fluorine over here, and I had an ethyl group on one end, right? Fluorine. Now this is not entirely impossible, especially over here, when I had the fluorine over here, and if I was going to have a methyl group over here as well, ethyl group, sorry, if I had an ethyl group over here, this is not entirely impossible to create. Let me just get rid of, this is not entirely impossible to create. Like a molecule like this could exist. I mean, I don't see why not. Of course, this is all on paper, but when we try to rotate it around and we try to get the water to line up with the fluorine, oh, the ethyl group doesn't line up, so let's just get the ethyl group there. I'm just rotating it around, and oh, we see that the water isn't being able to line up anymore. And this is when we have our racemic mixture, because now this fluorine, if I try to line up the fluorine and I try to line up the methyl group, we can see that the ethyl group and the hydroxyl aren't on the same spot. And this is when people say your racemic mixture is produced. Well, do we get 50-50? No, we don't know. We have to test it out, and we have to experiment. But this is an Sn1 reaction in VR. I hope the recording played out well. And I hope I was actually recording, because I didn't check. Shit.